This lesson is about 3D vectors and how to carry out operation with three-dimensional vectors and solve geometric problems. So how would you work out the magnitude of a vector in 3D? So if A is equal to xi plus yj plus zk, so we have a k component now, which is equal to the column vector x, y, z, then the magnitude of A is equal to square root of x squared plus y squared plus z squared. So if you think about 3D vectors, then if it goes x along this way, y direction here, z here, and this is our vector that we're trying to find, the distance of the vector. So we're trying to find out from the origin to z what the dimension is, so what the magnitude is. So this is the origin. And then if we first work out the base, then this diagonal here will be, because we've got x going across and y at the bottom, it will be a root of x squared plus y squared. And because this is a right angle triangle, so obviously we can use Pythagoras to find out that diagonal. Then if we want to find out obviously the length or magnitude of x, y, z, then it's this diagonal plus this z make a right angle triangle. So that means it will be square root of x squared plus y squared plus z squared. So that's how you get the magnitude of A. How would you work out the unit vector in 3D? So the unit vector is denoted by A hat, which is equal to A over the magnitude of A, which is equal to 1 over square root of x squared plus y squared plus z squared times x, y, z. So it's very similar to how you deal with 2D vectors. As a consequence, the distance between two vectors x1, y1, z1 and x2, y2, z2 is equal to square root of x1 minus x2 squared plus y2 minus y1 squared plus z2 minus z1 squared. I feel like I have interchanged my 1 and 2. It doesn't really make a difference, but let's keep it consistent. y1 minus y2 squared and z1 minus z2 squared. Okay, so let's do some questions now on this topic. Find the distance between points A, 1, 2, 3, 4 and B, 8, 6, minus 5, giving you answer to one decimal place. So this is x1, y1, z1, and this is x2, y2, z2. Then distance between A and B is equal to square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared, which is equal to 1 minus 8 squared plus 3 minus 6 squared plus 4 minus 5 squared, which gives me 7 squared, which is 49, minus 3 squared, which is 9, and a 9 squared, which is 81. It is equal to square root of 139. I put that into my calculator, I get 11.7898, which to one decimal place is 11.8. The coordinates of A and B are 503 and 42k. So this is x1, y1, z1, x2, y2, and z2. Given that the distance from A to B is 3 units, find the possible values of k. That means square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared is equal to 3. If I substitute my values in, we get 5 minus 4 squared plus 0 minus 2 squared plus 3 minus k squared is equal to 3. Now, I don't like the square root sign, so I'm just going to square both sides. So I end up getting 5 minus 4 squared, which is 1 squared plus minus 2 squared plus 3 minus k squared is equal to 9. So I squared both sides. Okay, so I end up getting 1 plus 4. When I expand 3 minus k squared, I get 9 minus 6k plus k squared is equal to 9. So I end up getting k squared minus 6k plus 5 is equal to 0, which means k factorizes to k minus 5 times k minus 1 equals 0, which means k equals 5 or k equals 1. So we found the possible values of k. Find the magnitude of A is equal to 2i minus j plus 4k. So in this case, A is equal to 2 minus 1 and 4. Find the magnitude of A and hence find A hat, the unit vector in the direction of A. So let's find the magnitude of A first. It's going to be 2 squared plus minus 1 squared plus 4 squared, which is equal to square root of 4 plus 1 plus 16. Which is equal to square root of 21. A hat is equal to A over the magnitude of A, which is equal to 2 minus 1, 4, divided by root 21, which is the same thing as 1 over root 21 times 2 minus 1, 4. I want to write in ijk component. First I rationalize it, so I just get root 21 over 21 times 2 minus 1, 4, because I don't like a third in the denominator. So it's the same thing as 2 root 21 over 21i minus root 21 over 21j plus 4 root 21 over 21k. P is the point 307 and Q is the point minus 1, minus 1, 3, minus 5. Find the vector PQ. So that means P is equal to 307 and Q is equal to minus 1, 3, minus 5. So if I want to find P to Q is equal to, this is the origin, remember, so P to O plus O to Q, which is equal to minus 3, 0, minus 7 plus minus 1, 3, minus 5, which is minus 4, 3, minus 12. Part B, the distance between P and Q. So that means I need to find the magnitude of P and Q, which is equal to square root of minus 4 squared plus 3 squared plus minus 12 squared, which is equal to square root of 16 plus 9 plus 144, which is equal to square root of 169, which is 13. C, the unit vector in the direction of P to Q. That means P to Q, unit vector of that, is equal to PQ over the magnitude of PQ, which we just worked out. So it's going to be minus 4, 3, minus 12 over 13, which is equal to 1 over 13 times minus 4, 3, minus 12, which is equal to minus 4 over 13, 3 over 13, and minus 12 over 13. And if I want to write it in ijk component, it's minus 4 over 13i plus 3 over 13j, minus 12 over 13k. Find the unit vector in the direction of each of the following vectors. So if I want to find the unit vector, I first need to work out the magnitude of p, which is equal to 3 squared plus minus 4 squared plus minus 2 squared. Which is equal to square root of 9 plus 16 plus 4, which is equal to square root of 29. Then I need to work out the unit vector in the direction of p, which is equal to p over the magnitude of p, which is equal to 3 minus 4 minus 2 over root 29, which is the same thing as 1 over root 29 times 3 minus 4 minus 2, which is the same thing as root 29 over 29 times 3 minus 4 minus 2, which is equal to 3 root 29 over 29i minus 4 root 29 over 29j minus 2 root 29 over 29k. Okay, similarly for q, first thing I need to work out is the magnitude of q, which is equal to square root of root 2 squared plus minus 4 squared plus minus root 7 squared, which is equal to 2 plus 16 plus 7, which is equal to root 25, which is 5. So the unit vector of q in the same direction is equal to q over the magnitude of q, which is equal to 1 over 5 times root 2 minus 4 minus root 7, which is equal to root 2 over 5i minus 4 over 5j minus root 7 over 5k. The points A, B, C have position vectors 8, minus 7, 4, 8, minus 3, 3, and 12, minus 6, 3. Okay, so that means O to A is equal to 8 minus 7, 4. O to B is equal to 8 minus 3, 3. And O to C is equal to 12 minus 6, 3. Okay. For part A, find A to B. So A to B is equal to A to O plus O to B, which is equal to minus 8, 7, minus 4, because it's going in the opposite direction of O to A, plus 8 minus 3, 3, which is equal to 0, 4, 1. Minus 1, sorry. 0, 4, minus 1. Which is equal to 4j minus k. I want to work out A to C. It's equal to A to O plus O to C, which is equal to minus 8, 7, minus 4, plus O to C is 12 minus 6, 3, which is equal to 4, 1, minus 1, which is equal to 4i plus j minus k. B to C is equal to B to O plus O to C, which is equal to negative 8, 3, minus 3, plus 12, negative 6, 3, which is equal to negative 4, negative 3, minus 8 plus 12 is 4. 3 minus 6 is minus 3. And the last k component is 0, which is 4i minus 3j. Find the magnitude of a to b, a to c, and b to c. So a to b is equal to the magnitude of 0, 4, minus 1, which is equal to root of 0 squared plus 4 squared plus minus 1 squared, which is root of 16 plus 1, which is root 17. A to c is equal to the magnitude of 4, 1, and minus 1, square root of 4 squared plus 1 squared plus minus 1 squared, which is 16 plus 1 plus 1, which is root 18, which is 3 root 2. And the last one, which is the magnitude of b to c, is equal to magnitude of 4 minus 3 and 0. Let me just write that one correctly, 4, which means I get square root of 4 squared plus minus 3 squared plus 0 squared, which is square root of 16 plus 9, which is square root of 25, which is 5. Describe triangle ABC. So we've got root 17, 3 root 2, and 5. Since all sides are of different lengths, the triangle ABC is scalene. A is a 0.348, B is the 0.1 minus 25, and C is the 0.7 minus 57. So we have from the origin to A is 3, 4, 8. From A to B, so the origin to B is 1 minus 2, 5. And the origin to C is 7 minus 5, 7. Let's find A to B. A to B is equal to A to O plus O to B, which is equal to minus 3 minus 4 minus 8 plus 1 minus 2, 5, which is equal to minus 2 minus 6 minus 3, which is equal to minus 2i minus 6j minus 3k. A to C is equal to A to O plus O to C, which is equal to minus 3 minus 4 minus 8 plus 7 minus 5, 7, which is equal to 4 minus 9 minus 1, which is equal to 4i minus 9j minus k. And B to C is equal to B to O plus O to C. B to O is minus 1, 2, minus 5, plus 7 minus 5, 7, which gives me 6 minus 3, 2, which is equal to 6i minus 3j plus 2k. We hence find the length of the sides of the triangle ABC, which means I need to find out the magnitude of A to B, which is equal to magnitude of A to B, which is equal to the magnitude of minus 2 minus 6 minus 3, which is equal to square root of minus 2 squared plus minus 6 squared plus minus 3 squared, to 4 plus 36 plus 9, which is square root of 49, which is 7. Magnitude of A to C is the magnitude of 4 minus 9 minus 1, which is equal to 4 squared plus minus 9 squared plus minus 1 squared. which is 16 plus 81 plus 1, which is equal to square root of 98, which is equal to 7 root 2. And the magnitude of B to C is equal to the magnitude of 6 minus 3, 2, which is square root of 6 squared plus minus 3 squared plus 2 squared, which is 36 plus 9 plus 4, which is square root of 49, which is 7. Given that ABC is equal to 90 degrees, find the size of angle BAC. So for C, we know from A to B to C is 90 degrees. But we also know A to B is 7, A to C is 7 root 2, which is the hypotenuse, and B to C is 7. So ABC is a isosceles right angled triangle. So that means these two are also the same, which means therefore angle ABAC must be equal to 45 degrees. Okay, the next thing you need to know is what, if a 3D vector, the angle it makes with the positive x-axis, with the positive y-axis, and the positive z-axis. So, because if you look at the first one, if vector A is equal to xi plus yj plus zk, so we're looking for the angle it makes with the positive x-axis, then what we do know is we do know the magnitude of A, okay, which is that. We also know the x. So we got adjacent and hypotenuse of what we do know of the triangle, so of a right angle triangle. So if we've got adjacent and hypotenuse, we've got cos, obviously. So the cos ratio, so cos theta x must be equal to adjacent over hypotenuse, which is x over the magnitude of A. In a similar way, if I were to look at the y1, so the y1 would be here. So this is theta of y. Then we know the magnitude of A and we know this value, which is y. So again, we've got adjacent and hypotenuse of theta y. So that means we've got the cos ratio. So it becomes cos theta is equal to y over the magnitude of A. In a similar way, if we look at z, so if we think about the z, so this is z, and this is theta z, right angle triangle. Again, we've got adjacent and hypotenuse. So cos theta z is equal to z over the magnitude of A. So these formula are not given to you. You just remember it's a cos ratio, and it's always x, y, z, depending on which axis you're looking for. It's x, y, z over the magnitude of A. And it's always the positive x-axis or the positive y. The angle it makes the positive x-axis, the positive y-axis, and the positive z-axis. So theta y and theta z. Okay, so let's look at an example. Find the angles that the vector A is equal to. So A is equal to 2 minus 3 minus 1 makes with each of the positive coordinate axes. So the first thing we need to do is find the magnitude of A. So it's going to be 2 squared plus minus 3 squared plus minus 1 squared, which is equal to square root of 4 plus 9 plus 1, which is equal to square root of 14. Which means if I want to find out theta x, cos of theta x will be equal to the x component, which is equal to 2 over magnitude of A. A similar way, cos of theta y will be equal to minus 3 over root 14, and cos of theta z will be equal to minus 1 over root 14. Okay, which means theta x will be equal to inverse cos of 2 over root 14, which gives us a value of 57.7 degrees. That makes sense because 2 is positive, so it's going to be a positive. It's going to be a acute angle. So it's going to be slightly above the x-axis. Okay, theta y here will be able to equal to inverse cos of negative 3 over root 14, which gives us a value of 143.3 degrees. That also makes sense because the j component is negative 3. It's going to be below. It's going to be on the y-axis. It's going to be more than 90 degrees and obtuse. So if it's a negative, it's going to be an obtuse angle that he makes. Theta z is equal to inverse cos of negative 1 over root 14. So again, because it's negative, we're expecting an obtuse angle. We end up getting 105.5 degrees. Okay, the diagram shows PQR. Given that P to Q is equal to 3 minus 1, 2, and Q to R is equal to minus 2, 4, and 3, show that PQR is equal to 78.5. So we're trying to find out this angle, which is X. Okay, so the first thing we need to do is find the magnitude of P to Q. Okay, so magnitude of P to Q is equal to magnitude of 3 minus 1 and 2, which is square root of 3 squared plus minus 1 squared plus 2 squared, which is equal to 9 plus 1 plus 4 square rooted, which is square root of 14. In a similar way, we've got the magnitude. We have to work out the magnitude of Q to R, which is equal to the magnitude of minus 2, 4, and 3, which is equal to square root of minus 2 squared plus 4 squared plus 3 squared, which is 4 plus 16 plus 9, which is square root of 29. So if I draw another triangle next to it, then what I've just worked out is, if this is PQR again, then I've just worked out the length of this is root 14, the length of this is root 29, and we're trying to find out X. First thing I need to work out is the magnitude of P to R before I can do anything else, because I obviously have to use the cosine rule. So P to R is the same thing as P to Q plus Q to R, which is equal to 3 minus 1, 2 plus minus 2, 4, 3, which gives me 1, 3, 5. So the magnitude of P to R is the magnitude of 1, 3, 5, which is equal to the square root of 1 squared plus 3 squared plus 5 squared, which is square root of 1 plus 9 plus 25, which is equal to square root of 35. So what I do know is this is square root of 35. So using the cosine rule, using cosine A is equal to B squared plus C squared minus A squared over 2BC, we get cosine of X is equal to, so this is A, B and C don't matter which way around it is, so be root of 14 squared plus root of 29 squared minus root of 35 squared all over 2 times root 14 times root 29. So X will be equal to inverse cos of 14 plus 29 minus 35 over 2 times root 14 times root 29. Now, if we put that into a calculator, we get the answer 78.5, which is what we're trying to get.